Hello guys, welcome back to my YouTube channel. Today let us discuss about a VLSI fabrication. At the first, let me give you an introduction to a VLSI fabrication. A VLSI, that is also called as a very large scale integration, is a process of creating an integrated circuit with extremely high transistor densities. It involves a complex series of steps to manufacture a microchip that powers a wide range of electronic devices and from a smartphone to a supercomputers. A thin film deposition is a critical process in a VLSI manufacturing where a material are deposited in a layer onto a semiconductor wafer, and this technique is used for creating an inserting the technique is used to create an inserting and a technique and a conductivity and the semiconductor layer that forms a complex circuit with integrated chips, and the various deposition methods are employed in this, and the including a material vapor deposition, that is a PVD, chemical vapor deposition, that is a CVD, and an atomic deposition layer, that is ALD. The choices of the technique depends on the surface of a material and the thickness required to each layer of the thin film deposition, as you are seeing in the picture. Vapor presentation of a VLSI fabrication, that is a vapor slicing. A raw silicon ingots are sliced into a thin circular wave using a high precision. So this creates a foundation for an integrated circuits and a microchip. And the surface is polishing, that is a wafer surface of a multiculus polished to a micro like a finishing, removing any imperfections of and ensuring a smooth foundations or a subsequent fabrication steps. And the cleaning and an inspection, that is a vapor undergo a rigorous cleaning process to remove a contaminants, that is followed by a compressive inspiration to ensure that meet strictly quality standard before advance next stage. The oxidation and the diffusion, that is and the thermal oxidation, silicon wafer are exposed to the high temperature in an oxidizing temperature of the surface and creating a thin layer of an silicon dioxide, that is SiO2, and on the surface this surface is insulating a layer in an integrated circuit. And the next one is that is a diffusion, that is a dopant atoms are introduced into a silicon substrate through a diffusion process, allowing for a creation that is a PN junction, as you have studied before, and which is essential component in the transistor and the semiconductor devices. And the controlled diffusion by a preferentially controlling temperature, time and concentration of the adopt sources, and engine specific dopants perform within a silicon, and an enabling fabrication of the complexes is called as a structured circuit. And now let me tell you, that is a photolithography. That is a photolithography is a key process in a fabrication of an integrated circuit. It involves a transferring a pattern from a photo mask into a light services sensitive photoist layer that on a semiconductor wafer. That is, this allows the precision patterning and exiting these features on the wafer surface. And this photolithography is a process that includes a coating of a wafer with a photoarrest and exposing the resist of a UV light through a photo mask, developing an exposed rest and extruding and underlaying layers. This enables the creation of an intricate circuit designs that defines a modern integrated circuit. As you are seeing in the picture, that is a photo arrest. The mask aligned. The maskers are aligned in that. Now, etching techniques, that is a precision etching. Etching is a critical process of a VLSI fabrication used to sensitively remove a material and create an circuit pattern with a micrometer scale and a precision. And the wet versus dry etching, there are two types, wet and a dry. That wet etching, I use a liquid chemical to dissolve any weight of unwanted materials, while the dry etching employs a plasma or an ion beam for a created controlled or anospatic etching. Masking techniques. The editing is a guide by a photolithographic mask which protect the certain areas from this process and allows those complex in a 3D circuit structure. Okay. Now, as you're seeing that is a ion implantation. That is, there are 4 steps. At the first, a beam generation. That is, create a beam on a higher energy ions, and ion extraction. That is, extract and accelerate the desired ion species, and the beam focusing. That is our third level. That is, focusing an ion beam into a target wafer, and the wafer implantation. That is, bombard with a wafer surface to the dope it with impurities. This is here the ion implementation is a critical steps in the VLSI fabrication and the process, allowing the precise control over the doping the semiconductor materials, and by generating the higher energy beam of desired in ion species, focusing into a target wafer. And now the bombarding the surface and dopant atoms can be incorporated in a crystal lattice, that is altering the electrical properties with a semiconductor. Now, metallization and interconnect, that is the final steps in the VLSI process, is packaging and assembly. This involves encasing an integrated circuit chip in a protective packages and connecting the chip's input and output terminal of an external pins or a LEDs. And these packaged chips can be mounted on a printed circuit board, that is PCB, or another substrate, or interconnection are made between a chip and components on the board. As you are seeing, you can see you can look over the pictures of a metallization and interconnect the board which is shown on the screen. Now, metallization and interconnects. Thin film deposition, that is thin film deposition. That is a thin film deposition. A metal like an aluminium, copper, or a tungsten depend on onto the wafer surface used a technique like splintering or a chemical vapor deposition to the form of in-connect layers. And the second one is the patterning and etching. That is a photolithography is used for pattern the metal layer of following an etching to remove the unwanted metals, leaving behind the desired interconnected lines with the wires. And the third one is the multi-layer interconnects. That is a modern VLSI chip have up to a 10 or more than 10 layers with a device connecting and them vertically, creating a complex 3D network interconnects. And the planarization, that is a chemical and mechanical polishing, that is CMP, is used for a flatten the surface between a metal layer and enabling a sticking stack multiple connects level. At the last, let me conclude my topic with a conclusion. That is all. As we conclude our explanation of an VLSI fabrication, we look ahead into an existing, the future, upcoming, and rapidly evolving a field. Emerging a technology like 3D integrations, quantum computing, and neuromorphic chips hold immense promises for pushing the boundaries of a semiconductor design and the performing. Thank you, guys.